Okay. So let's just put up what we've done here and introduce another term, which are high spin and low spin. So we have these two cases here, and again, we're considering how big is this octahedral crystal field splitting energy compared to a pairing energy, the energy involved in pairing electrons together. In a weak field, the splitting energy is small, so electrons are placed singly with spins parallel to the fullest extent in all the sets of orbitals. In this other case, with a strong field, the pairing energy is smaller than the splitting energy. Strong field, you have a big splitting energy. And so in that case, with the splitting energy is large, you're going to put all your electrons in and pair them up in T2G, and don't put any electrons in the EG sets of orbitals until you've completely filled your T2G set. So the net result of this is, for a weak field, you have the maximum number of unpaired electrons. So see, you have a maximum number. You have 4 electrons. All 4 are unpaired. So that's the maximum number of unpaired electrons. And this is referred to as high spin. And in the other case, you have the minimum number of unpaired electrons that you can have. And so you have this one set that's paired here. So that would be considered a low spin case. We can also talk about the stabilization energy of these two cases. And so we have the crystal field stabilization energy. So why don't you go ahead and tell me, for a weak field case, what is our stabilization energy? Okay, let's just take 10 more seconds. Okay, pretty good. So let's work this out. So first we consider how many electrons we have in the lower set of orbitals. So we have 3. Those 3 are stabilized by 2 fifths. And then we have 1 in the upper set, so we have 1 at 3 fifths times the octahedral crystal field splitting energy. So this ends up with minus 3 fifths times the octahedral crystal field splitting energy. And notice why A is not correct. You don't have the symbol for the octahedral crystal field splitting energy. On a test, you need to make sure that you remember to write this term. So this was a little test so that you hopefully emphasize that you want to have that there. All right, so that's for this one. Let's look at the low spin case, the strong field case, and do our crystal field splitting energy for that. So in this case, we're going to have 4 electrons times minus 2/5 times the octahedral crystal field splitting energy. And so that's equal to minus 8/5 times the octahedral crystal field splitting energy. And some books will also indicate, and they'll say plus PE to indicate that there's pairing energy that's associated there. So it's not